Why? I said 15 minutes running the numbers. I'm telling you, get me these numbers. Look now. Is that not even doing it? It has to be a good trade. No wonder finance invented data science to make this process a whole lot easier. Today, we're going to look at how one finance concept, when applied to data science, can help us understand the secret to human motivation. There you go, basket. Ever tried to compare Google Trends data across countries and found it impossible? I stumbled across this problem myself when I tried to work out what it is exactly that drives people. I thought it would be an interesting multilinear regression video where I just grab the Google Trends data for motivation, some other cool, clever variables that I find to optimize, and off we go. All good fun, but I wasn't ready for how wrong I was. Because last week, we found that it's impossible to compare different countries to each other using the Google Trends API. But don't worry, I've had a burst of inspiration. We're going to borrow something from the world of finance to solve this very problem. So, off I go to the stock market. Good job I brought this basket. One of the beauties of data science is how you can take the underlying concepts, methodologies, and apply them to different domains. So, to see this in action, we're going to take my basket on a bit of a journey to the world of finance and specifically to the stock market. So the stock market, as you are probably aware, is a way to buy and sell equity, stock, shares, whatever you want to call them. They represent a partial ownership in a company. This partial ownership entails a holder with voting rights and often dividends as well, which are like a small bonus for being the owner of a share. These are things that individuals can buy, like you and I, but shares can also be owned by big companies such as banks and other financial institutions, or private companies as well. The stock market can be seen as an economic measure of the country. So when the country is doing well, stocks are going up and we're in a bull market. And when the country is doing poorly, then stocks are going down and we're in a bear market. Now, this is a pretty big oversimplification. There's a lot of nuance that goes into this, and human behavior is incredibly hard to predict. But for our purposes, this level of complexity definitely works. So how do we track the stock market as a whole? Well, the simplest thing to do is to take every single stock that's on the exchange, get its price, multiply them together and add them all up, and then you have the total value of the stock market. In reality, it's done a little bit differently. You've probably heard of the S&P 500, an index built up of the 500 biggest companies in the US. This is used as a way to measure the health of the US market as a whole. For a few reasons. First, that the 500 stocks cover about 80% of the US market, which is good coverage. And the second is that the stocks within it tend to be pretty liquid. There's usually buyers and sellers, and so the stocks can trade hands on a regular basis. Because they cover the majority of the market, it's a good representation of the market as a whole. Why 500 though? Well, initially when I was writing the script, I was theorizing that this was because they didn't have the computational power to be able to calculate these automatically, and so doing 500 calculations by hand would be incredibly slow and painful, let alone doing 1,000 plus. But actually, I found out that S&P 500 came about because a new automated calculation methodology was brought into play to calculate this index. I mean, they came about together. Before that though, people were doing them by hand and they had to be much, much smaller. Now we have the computational power to do the whole market. I mean, what's a few thousand companies in all of the big data world that we have right now? But actually, we don't. We stick to the S&P 500 for a few reasons. First is that there's a big overhead in collecting all the data that you need to maintain an index of all the companies in the world. And the second is that the smallest companies tend to be a lot less liquid. There's not so many buyers and sellers, and so we can't as obviously see what a fair price is, and the data might become stale. The pros of adding them are outweighed by the cons. And this conversation pops up all over finance. The UK has the FTSE 100 to track the 100 biggest companies in the UK. There are commodity indices that can be used to track the general health of sub-areas of the economy such as oil or agriculture. And CPI, that is made up literally of a basket of goods that are used to track inflation over time. So if a basket of items can be used to measure the entire stock market or inflation, why not use it for search volumes as well? So if I want to use this concept, what I need is some idea of the most commonly searched terms in each of the countries so that I can use them to build an index for each country. And unfortunately, that idea was a little bit optimistic. I couldn't find a comparable source that would give me lots of different countries' top search terms, but I did find one that did both for the US and worldwide, and also had the monthly average totals. So it seemed like a good place to start, and we'll deal with the other countries a bit later. So this is great. I can use this. I can get the data for the most commonly searched terms using my chaining methodology for last time, and I can use that to build up my basket and benchmark it to the real world totals. There's just a couple of problems that we still need to solve.
One of which is that motivation isn't one of the most popular search terms, and so I don't have a benchmark for it. The way we get around this is by averaging the scaling factor across all of my basket elements and using that to get a general US scaling factor that takes us from Google Trends units to real-world absolute search volumes. Now, there are a couple of caveats here. One is that I don't know how representative my basket is. I would have loved to have built a huge index like the S&P 500, well, maybe not quite that big, but the problem was I kept on getting temporarily suspended from Google Trends for downloading too much data. So in the end, I had to settle for 9 items in my basket. It's not as big as I would like, but it's better than nothing. The other problem that I have is that different search terms are going to be popular in different countries. And while Facebook and Instagram are really popular over here in the UK and the US, in places like China, that would be WeChat instead. I wouldn't put WeChat in my basket because it's not representative of countries around the world when it's not really used very much outside of China. But it is highly representative of China. The other problem I have to solve is that while I know how to scale US data to match the benchmark, I don't have that for other countries. So I need to come up with a way to scale other countries' data. In order to tackle this problem, I had a think of things that might impact search volume. So one obvious thing is population size. So we know that the US has about 5 times the population of the UK, so we might expect that searches would be about 5 times the amount US versus UK. But actually, I think we can do a little bit better than that, because internet access is not uniform across the entire population. There are still areas where people don't have internet access. There are older people who never learned how to use computers growing up and have decided that they never will learn. There are babies that haven't yet been given their first tablet. Or there are people who just decide to opt out of technology altogether. The percentage and the makeup of these different groups of people is going to vary a lot depending on which country it is. So a more accurate tool that we could use would be internet user percentages. I actually managed to find this data, and by combining it with population data, I was able to get a rough scaling factor between US users and the US scaling factor, and then other countries' users, so that I could have a country-specific adjustment to the scaling factor. So this means we have a method to calculate the absolute number of searches for every country and every term. Let's get going. Now, with that in mind, I do have to make one caveat, because in order to compare motivation across different countries, we can't just look at the absolute search volume for motivation, because if we did, we'd immediately conclude that the US is far less motivated than the UK because far more people search for motivation, when in reality, the answer is that there's just more people in the US than there is in the UK. So instead, we have to look at something a little bit different. In order to solve this problem, I would need to look at motivation searches as a proportion of total searches for this country. And what do I have to do that? I've already got my basket for each country. So all I can do is take total motivation searches, divide them by total country searches, and then I'm going to get the proportion that I need to compare. You might have noticed something here, because if I do this, won't my scaling factors just cancel out? The answer is yes, they will cancel out, rendering all the work we've done so far completely useless. Except it's not completely useless, because if I'd started this video by saying that we could just divide the raw searches for motivation by the raw searches for the basket, we wouldn't have known we could do this. You'd be confused, I'd be struggling to justify it. We needed to go on this adventure to find out how we could build this model in a way that actually makes real world sense. Until we did this analysis, we didn't know we could do this. There's also an extra benefit of this. I was aware that after all the scaling that we did to get all the data comparable, and then having to scale for each term and each country, that's a lot of scaling factors with a lot of errors accumulating. So if we can just remove some of those scaling factors, then that removes some of those errors that could be causing issues. We've got rid of some of the noise polluting our numbers. So yes, we did work that is unnecessary to be able to build this model and do this calculation that we want to do. But that's okay, because in doing so, we understood our model and we were able to build something that was far more robust and far more practical in the end. And that's what made it worthwhile. So where are we at now? Well, so far we've built a scientifically robust model that allows us to compare motivation across a variety of countries. But all that hard work was just the setup. Now it's time for the fun part. Drawing insights. Which countries are most motivated? Do people work harder knowing that their shareholders are going to get a bonus just due to their thankless hard work? And are the winter blues a real thing? We'll be diving deep into those questions in the next video in this series. Do you have any interesting data science topics that you think we should explore? Let me know in the comments below. Otherwise, like and subscribe, and I'll see you in the next one. Thanks for watching, and keep being evil.